one final example of being able to find the key components of a rational function and then to sketch that function, we have this x plus 2 over x squared minus x plus 6. First thing we're going to do is determine if there's any symmetry. All right, so to determine if symmetry, we plug in negative x, and so we get negative x plus 2 divided by negative x squared minus a negative x minus 6. And then simplifying this, the only thing that would really simplify is the denominator. So we'd have negative x plus 2 divided by x squared plus x minus 6. And notice that it doesn't look like the original. All right, so these two terms are different. And clearly not every sign changed. Okay, there's only 2 sign changes. There's not 5 sign changes. So this means that there is no symmetry, at least with respect to the origin. So no symmetry with respect to origin or with respect to, so we say no symmetry with respect to the origin or the y-axis. Okay, all right. So next thing we're going to do is we're going to determine if there's any asymptotes of this function. So let's start with the horizontal, x plus 2 over x squared minus x minus 6. And so looking at the degree of the numerator and the degree of the denominator, we finally have a difference, unlike the other videos. And so this degree is 1. This degree is 2. And remember, if the degree of the numerator is greater than the degree of the denominator, okay, so the degree of the numerator is, less than the degree of the denominator. And so what that means is that we are going to have the equation y equals 0. Okay, so that's going to be our horizontal asymptote, which is the x-axis. Okay, so just remember that's the equation of the x-axis. All right, now, next thing we're going to do is find some holes in this if they exist. That means we have to factor. The numerator is going to be prime. For the denominator, well, we just need to find 2 numbers that multiply to be -6 but add up to be -1. I think 3 and 2 are going to work really nicely. And to get a negative, we should have -3 and +2. Right? Now, I want you to notice that we have a common factor of x plus 2. All right, so that means that there's going to be a hole in this rational expression, in the graph of it, the rational function. So there's a hole when x plus 2 is equal to 0 or when x is equal to -2. All right, so there's a hole there. And to find the coordinate, what we're going to do is we're going to cancel those out. And now we have 1 over x minus 3. And we're going to substitute x equals -2 back in. So it'd be 1 over -2 minus 3, or -1/5 is the y coordinate. So we're going to say that now there is a hole at the point -2, -1/5. All right. So the other thing we need to do is we need to find, before we start finding any intercepts or anything of that nature, we just need to go through and determine where there's a vertical asymptote for this. And that's where we're just going to deal with the simplified version from now on. So 1 over x minus 3. And all we're going to do is set x minus 3 equal to 0 or x equals 3. All right. So now we have 3 pretty important components of this graph. So we certainly have y equals 0. Now we have this hole, and then we also have a vertical asymptote at x equals 3. So let's start graphing this from what we know. Okay, so remember, we have the x-axis. I'm going to change the color so that way we can see it. All right, so let me use this green, right? And so there's a horizontal asymptote right here on the x-axis. So essentially what we're saying is that it'll approach but never reach that for the far end behavior. Remember, we also had an asymptote at +3 in the vertical flavor. So 1, 2, 3. So we should have a vertical asymptote right about here. And the other thing that we have is we have a hole at the point -2, -1/5. So if I go back to, and it should have a hole, and I made that just about on the x-axis. Okay, so if I draw this, we're going to have a hole maybe right about, if this is 1, so we have -2 right here. So probably a hole right about here. Okay. All right. So next thing we're going to do is we're going to find some points on this. And some points are probably helpful with the intercepts. So let's start there. So let's start by finding h at 0. Okay, so 0 plus 2 divided by 0 squared minus 0 minus 6. Okay, so I just went up here, plug 0 back in, and that just gives me 2 over -6 or -1/3. Okay, and so we get the point 0, -1/3. All right, so let's go down here and we have the point 0, -1/3, which might be right about here. And so it's kind of looking like to me that we're going to have like this sort of behavior. Okay, but we'll find a few more points before we can say that with any certainty. Let's see if we get an x-intercept. And the x-intercept is when we set the numerator equal to 0. Okay, so f, remember we had x plus 2 equals 0. That was our numerator. Okay, but that gives us x equals -2. And that's not going to work for us because remember, that was a whole. Okay, so, and that's because remember, with the simplified expression, we're really looking at 1 over x minus 3. So what we would really do is just set 1 equal to 0, and that doesn't make any sense. Okay, so what we're saying is that there are not going to be any x-intercepts, which actually makes a lot of sense because we said that the x-axis was an asymptote. Okay, so there should be no x-intercepts. All right. And again, that should be the case most of the time when we have a horizontal asymptote at the x equals 0 or y equals 0, excuse me. Let's find a few more points. Let's now find h at let's see. So maybe we should find one more point over here. So let's do -1. And then also, let's see what happens with 4 and 5, because we really don't have any idea as to what's going on this side. Although I kind of have an idea just from doing this a lot of years. So let's try maybe something like 2, maybe something like close to the axis, and then 4 and 5. So we'll find h at 2, h at 4, and h at 5. All right. Now, remember, we can use the simplified expression. Okay, let me just show you guys what would happen if I used this expression versus the simplified expression. Okay, so we can just use this. Okay, but just for h at 2, using the original, we'd have 2 plus 2 over 2 squared minus 2 minus 6. All right, and that would just leave us with 4 in the numerator. In the denominator, that would leave us with 4 minus 2 is 2. 2 minus 6 is -4. All right, so that would leave us with -1. However, let's say I used h at 2, 1 over, remember we had 1 over x minus 3. Okay, and so h at 2 would become 1 over 2 minus 3, which is 1 over -1, which is also -1. All right, so it's probably easier for us just to use this. And I was just showing you that you could use either of these, okay? But we're just going to use the simplified version. So we have the point 2, -1, right? At 4, we would have 1 over 4 minus 3, which is 1 over 1, which is 1. So we have the point 4, 1. And then with 5, we'd have 1 over 5 minus 3, which is 1/2. So we'd have the point 5 comma half. So let's plot those points, and that should give us a pretty good idea as to what our function will look like. So we have 2, -1, which is down here. So it looks like what's going to happen, at least what I think is going to happen, is we're going to have this behavior. Remember, we have a hole, right? And then we had the point 3, 1, which is right here. And then we had the point, I'm sorry, 4, 1. And then we had the point 5 comma half. And so I think what we're going to get is we're going to get this sort of behavior. Oh, that looks awful. Let me try that again. Hopefully I can do better this time. All right, so let's try. Oh, Third time, maybe. So there we go. All right. And then just like when I was in 7th grade, I just made the dots bigger. It didn't work. All right. So that's about what our function should look like. Okay. If I'm just kind of approximating this. All right. Now, of course, we can use our graphing device, right? And also what I'm going to do is I'm going to graph both the original function, and then when I'm done, I'm going to graph the simplified function, the y, or the 1 over x minus 3. So we had x plus 2, right? And I always have to delete this. And then we had x squared minus x minus 6. All right. And remember our asymptotes. We had y equals 0, which is the x-axis. So that looks good. We also had x equal 3. All right. Some points that we had. All right. Now, check this out. I also want to go through and say our whole. So remember, we had the point -2, comma, -1/5. All right. Now, that point doesn't exist on this graph. Okay. So right here, I plotted it. But if I go down here and try to hover over it, there it is. It's undefined, and there is a hole in that graph. Okay. So unfortunately, there's no way for us to be able to keep that hole on the graph, but we just have to understand that that hole exists in the graph. Okay. Some other points that we plotted. So remember, we had the point 4, comma 1. We had the point 5, comma 1/2. Okay. On the left side of the graph, I honestly forgot. We had 2, -1. And then also we had 0, -1/3, it looks like. Okay. I don't think we ever plotted that. Oh, we did. It was right about here. So 0, -1/3. So let's plot that one. All right. So those are all the points that we found from before. Okay. So that looks really good. All right. Now, last thing I want to do is let me go through and plot the simplified version of the function as well. All right. And I'm going to keep all these points, and I'm going to keep the asymptotes. All right. And I'll show you the difference as to what happens. So I'm just going to change this into 1 over x minus 3. All right. And I want you to notice that we have almost the exact same function as the unsimplified version. However, remember we had that point 2, comma, -1/5. Well, now that point exists because it is in the domain of this function. Okay. But the original function that we had, which was x plus 2 and then x squared minus x minus 6, notice that that point was not in the domain. Remember, it was undefined. Okay, so Desmos tells us it's undefined. Desmos wouldn't lie to us. All right, so excuse me. That's it for our rational functions. Okay, so hopefully you were able to understand how to graph the asymptotes to be able to how to get a fairly rudimentary but a decent graph given just without using graphing devices, but then also how to check using a graphing device. We're almost done with chapter 2. The last thing that we have to do in chapter 2 is to take a look at rational as well as polynomial inequalities. So that's more algebraic than it is graphing. So we'll see that in our next section.